Hey, this is Steven from Legit Tutorials and the Green Engineers, and welcome back to my product development series with the Shredder. I think it's like episode 16 or something. So basically what we're going to do now, I placed the order this morning. So we are going to continue on with the stand, and then the hopper, and then the motor mount. So what I'm thinking is that first we're going to do the stand, because that's going to be something that people are really looking to use, and then that's going to be best with the to use with the motor mount, and then we could look at some motors that we could use that use standard AC. Even if they're brushed motors, that's fine. So let's go ahead and take a look. So what am I going to do first? Am I going to do the stand? I'm going to do the motor. Stands is pretty easy, so we could do that. Do we have some of the stuff from the multi-shooter for the stand? No. No. That's not what it actually looks like. So I'd probably use the same stuff that we used on for this extruder guy here, and we can look at that. I have it down over here on the floor, and so we could kind of go into what that would entail. So let's go ahead and look at here the shredder. Let's go back. This is wrong, this is wrong. And I'm pretty much going to do exactly what the multi-shooter has. So again, there's going to be a bracket here, a bracket here, and probably a bracket around the bottom with a little cutout on it or something. With this, I'm not too worried about. This one is just going to be shear, so just a bracket here, you know, just a bracket across, and then with the pieces going down, bracket across, pieces going down. So let's go ahead and get, let's use the more precise calipers. So I have, of course, the Harbor Freight carbon fiber ones that are very precise, and then I have my eye gauging calipers. I'm gonna go over here to the multi-shooter, which is over here on the floor, and I have some pieces here that go into each other that I would definitely think that I could use. It's a little small, but we could also go to the shop and look at some thicker pieces. So, and these are painted. Paint slides off because of how it is. Okay, so let's look here. So what we're gonna do is let's do stand. Oops. Stand. Okay, so, and here in the stand, we're going to do one new one. We're going to call it 12-inch leg. And again, this is all going to fit in a flat rate box. It should actually be pretty light. This component's pretty light. So we could probably even go bigger than that. Because it needs to be at least the size of this trash can here. Be able to stick this trash can underneath it. 12 inches. It's 12 inches. So yeah, I'm thinking 24 inches or at least up to my hip would be nice. That's a lot of leg, and that's a lot of sway. And you know, if you're doing any sort of thing from the floor, it's going to be very difficult to control, and that's 3 feet up. So what I'm thinking is that it could possibly be It could be included inside the container with this smaller shredder because again it's going in the flat rate box, and the flat rate box is 12 by 12 by 3.5. So there is some room there. This guy here will fit in the small flat rate. So what would be nice is if we could fit this all in the large flat rate and possibly even the motor and the side pieces. So these are 12 inches, and we have 4 of these plus a section where these slide into, and then down further, right? So basically we have 12 inches and then a joint and then another 12 inches. So 2 feet plus a little bit. So it's a small stand. You could stick a small bucket underneath it and have it sit on a table or whatever and bolt it down the table. Maybe not necessarily down to a floor. Maybe bolt it into a piece of board on the floor that you could step on. I mean, that's probably the best way of doing it. Do some carriage bolts and drill some holes, and then put some bolts on it, and then step on the board, and then use the breaker bar. And that way you're holding it. It's basically attached relative to you, and it's attached to the floor. But we still only have a 12-inch base. I would like to get a bigger base. Like like a 12 by 12. Because this bucket right here is at least 12 inches in diameter, I believe. Well, this is only 9 inches. So that would be fine with a 6-inch room. Oh, but these are 12 inches, so this bucket will fit perfect. Okay, so basically what I'm thinking, okay, it's 12-inch legs, so let's see what I'm using here on the multi-shooter. So if I start producing the multi-shooter again, we could get all the same. This is 0.632. So here, oops, 0.632 by 0.632, right? It's a little bit bigger the other way. That's the tolerance, I guess you could say. The other way is 636. So the other way is about 4 thousandths bigger, but that's okay. Then we have internal thickness. Got burrs there, it looks like. I mean, internal thickness is not that important. I was going to say, I wish I had my backpack here with my deburring tool, but I don't. So let's just take an estimate here. 1/2 inch. Estimated on the inside. Like so. And 12 inches tall, made out of steel. And that is the arm. And then here we have a joint, which basically this piece is a standard piece of steel, and it actually slides right in. There's a little bit of play, as you could hear, but this guy slides right in there. I mean, there's a little bit of deburring here, so you have to go in there and file it down, file the edges down so that it fits in there, but that's okay. So inside is about 633. So this is, I can call it sleeve. And again, this is a slightly different specific wall size material. Same standard steel. and off the shelf, regular off the shelf, and it'll actually work to slide that guy right in there. And you see it's actually 0.632 on the inside. This is the inside. And then we're going to do a rectangle again. And the outside is 0.754 one way. The other way is a little bit bigger. 0.754. Oops. And this particular sleeve that I have here is about 2 inches long. And there you go. So now this is the sleeve, and then this is the standard leg. And we could also run analysis to see if this will actually, buckle or do whatever. Let's see. So that's pretty nice. And, like I said, the tolerances are pretty good. Or it just slides in there easy. I mean, there's a little bit of tolerance, but if we have all of these things being held together, it might be a little better. So, pretty much what we're going to do, and then we're going to call this stand assembly here, is let's go ahead and drop the shredder assembly in there. You see it's definitely not going off of the right center, but that's okay. Okay, so now what we're going to do is we're going to go off of this side. And then what I would like to do is I would like the stand to be actually a 12 inch by 12 inch by 12 inch base. So a little bit bigger than this guy. And what that will mean is that it's going to be very easy to do the big shredder, because the big shredder is basically the same exact, would be the 12 by 12 by 12. And so that way we could kind of get rid of any sort of issues there. So now what I'm thinking is that we're going to go off of this, this, and this. Like so. And we're actually not going to go off of this here. We're going to have this in a different thing here. So this, of course, is, let's say, 1 inch. And call this mount. And obviously, because we don't have staggered, it's going to be the same on both sides. Oops. 1 inch tall. By 6.5. And from what I remember, this is basically half by 0.75. Perfect. There you go. This obviously is going to be a little bigger, just to leave some tolerance. Okay. Okay. Now, this doesn't have to be too thick. I'm thinking 1/4 inch is probably overkill. Probably 1/8 of an inch is probably going to be okay. Steel, regular steel. It depends, and 1 inch, 1/8 inch thick is going to be pretty easy to get a hold of. Now this, obviously we have 2 of these. So now in the stand assembly, let's drop in the mount after we close that. And let's joint it. Beautiful. Oop. Turn off joints. Okay, and there we go. So now this is going into this threaded region, and that guy's on there. So now what we need to do is we need to have an area right here where this guy branches off. And then basically goes down. So I want a 12 inch by 12 inch base. So it's going to increase this guy by about, it's going to stick out about 3 inches this way, 3 inches this way. Just to kind of open it up. I mean, we can go straight down, but then that means that this guy over here is going to have to be 6 inches. And I can't just cut all of these at the same length, which is unfortunate. So it should be okay how it is. So how do I want to do it? I think maybe the 6 inch by 6 inch is okay. It's not going to be as stable as 12 inch by 12 inch. You can look at it, but I'm thinking right now that we're just going to do the 6 inch by 6 inch. So let's make the sleeve a 1 inch sleeve. So let's make this a 1 inch sleeve. Sleeve. And then we put a couple sleeves in here. And then obviously we're going to cap the sleeves. Right. Do we have enough room? We do not. Okay. It's gonna make it very difficult to put a bucket underneath that thing. That's why I'm thinking put some sort of bar here, weld it, have it go straight out, go to this guy. It's going to be hard to manufacture. This is going to be easy. You just lay a bead. Maybe I should have put those bolt holes closer in the center. Alright, it's still not too late to do it. Still not too late to do it in the drawings, to put this in the center. Or what we could do is, let's say that this guy in actuality is like down here or something. This plate extends down a little bit. Let's say in actuality it looks like that. I mean, again, this thing is supporting 25 pounds, so. Oops. Remember, we could always change this after that first one. Okay. All right. So now we have our first leg. Goes in there. Come on, Fusion. Don't be so freaking laggy. Okay, so there's the first leg. And obviously, again, like I said, the top of this sleeve would be capped in actuality. What the heck? Fusion? Why are you being so weird? There it goes. Yeah, maybe instead of this bracket, what if we put these with some 90s on them? Kind of interesting. Okay. What the heck? It's getting super laggy. Oh, they need to fix this stuff. What the heck is going on? It's glitching hard, man. Oh, man. Come on. I mean, they just added the patch, so it might be an issue with the patch. Oh no. Come on. There's ground option. Okay. There it goes. Another thing that we could do is we could have this go straight up through this hole. And then we use this as a pin. What I mean by that is that we could use a cap or we could use a bolt hole where we weld this together and then we drill through all of it. And then we use a pin. So we hold this guy in here and then we drill through. And then we use a pin or a bolt, basically a bolt here. So we just bolt this together. And so basically this goes up through there. And we're going to lose a little bit of base, but that's okay. It's going to go up through here, and then we don't have to worry about capping it. That saves us a step of welding, and we just have to drill it. Because we are going to have to drill these anyways down here. The 2-inch, and I would like these to be 2-inch, because the 2-inch, as you saw there, the 2-inch gives it a little bit more stability. And these down here are going to probably be 2-inch, and it saves me a little bit of cutting. So let's copy this and paste. So basically what I'm saying here is, again, every time you weld, you have an issue with something not lining up right. And it's not that bad to have this thing go in all the way. But, you know, to have this thing just welded here, and you have the bolt goes here, you clamp this guy down, it holds this piece in, doesn't rattle around, then you hold this other piece in, doesn't rattle around. That would be a pretty good deal there. And this be 2 inches long, so 2 inches here, and then this is 12. Then we have another sleeve on the bottom. So one thing that I want to get right is how am I going to do a 4-way sleeve here on these, and then how is it all going to assemble, right? Because I do like this idea of just putting the 1/8 inch here, shimming these off a certain distance, probably putting it right along the edge, or I probably wouldn't make it this long, so that all you basically do is you line this edge up with this plate, and then you weld this guy onto here, and then you drill it. And of course what you're going to do is you're going to drill through the leg. Now the issue with this is that if you use a drill press, pretty much you have to be very, very right on with which leg goes where. So you're going to have to mark on here like 1, 1, 1, 1, or even dots, like 1 dot, 1 dot, 2 dots, 2 dots, 3 dots, 3 dots, 4 dots, 4 dots. I had that issue with these guys, these other guys, and it makes it very difficult because pretty much if you use just a drill press, all of these guys are kind of wherever they fall, wherever you drill it, that's just kind of where they end up, unless I make some sort of jig or you drill it in the same spot every time. And obviously I'm not doing pec drill and then do the actual drill. I'm just doing, you know, all the way, you know, just doing all the way with the standard drill. Anyways, that's enough for this video. We will continue on in the next video, and I will see you guys in that video. Take it easy. Peace.